So how do you find the change between any two numbers? Here's how you do it. The answer, Rodriguez, the answer is you subtract them. That's how. We'll put A, the answer, you subtract them. How do you find the change? You subtract them. Example. What's the change between 8 and 10? The change between 8 and 10. Can you say it again? 2. So I want to know the change between two numbers, just subtract them. 8 minus 10, it'll be negative 2. Or 10 minus 8 is positive 2. Either way, the change is 2. They're 2 away from each other. How far apart are the numbers? Well, that's the change between them. You subtract the two numbers. It doesn't matter which one comes first. It tells you, when you subtract them, it tells you how far apart those numbers are from each other. So let me show you how this formula works. Example 1. Example 1. I trust everybody's got this. Here we go. I'll write this down. Find the slope of the line passing through negative 1, 2, and 0, 6. I'll write that down. Find the slope of the line passing through negative 1, 2, and 0, 6. Now what we could do is we could do what Mr. Rodriguez did for warm-up. I can get my graph paper and actually plot negative 1, 2, and then plot 0, 6, and then figure out the vertical change over the horizontal change. We're not going to do that with this example. We're going to use the slope formula. Delta y, delta x. Remember, this is delta in the Greek alphabet, and it means change. Engineers throughout the years have just designated that letter to mean change. There's an airline called Delta Airlines. What kind of change is involved when you step on a plane? Your location changes from LA to New York. Delta. That's what they call it, Delta Airlines. So here we go. Change in y's. Okay, so between these 2 points, what are my y coordinates between these 2 points? 2 and 6, right? You guys with me? Let me subtract 2 and 6. Watch this. 2 minus 6, that'll be the numerator. The delta y, over delta x. Since I used 2 first for the numerator, I'm going to use the negative 1 first for my x's. So here's my x's. Here's my y's, right? So 2 minus 6 is going to be my numerator. Negative 1 minus 0 will be my denominator. Delta y, delta x. Change in the y values over the change in the x values. Watch what happens. Two minus 6, well, let's see. That becomes 2 plus negative 6. So I got a negative 4 on the numerator. Negative 1 minus 0 is a negative 1. Negative divided by negative. Positive, so this becomes positive 4. I could put 4 over 1, but it's not necessary. So the slope is positive 4. Our slope. Make a mistake?
No. Can you do it on the graph?
Sure.
I won't be able to do it.
Let's do it. Let me get some graph paper out here. I have my graph paper. You know, with this new smartboard, I have to find out where my graph item is. So we'll put that on hold. Actually, let me just go ahead and draw it. There we go. So let me plot the points. Negative 1, 2. Negative 1, 2. Okay, that was the first point. And then 0, 6. 0, 6, 1, 2, 3, 4, 5, 6. There's the 2 points. Let me draw a line through them. So a slope of 4 really means vertical 4, horizontal 1, yeah? I think that's exactly what we have. Up 1, 2, 3, 4, and then horizontal 1. So the graph proves it. Now, I chose to take 2 minus 6 when I did the calculation. I want to show now, I'm going to do it again, but I'm going to do 6 minus 2 now. To prove to you it doesn't matter which ordered pair you use when you set up your formula. Because you may be asking, how come, hey, Mungia, why did you pick 2 first? Why did you pick 6 first? 6 minus 2 for the numerator. Well, my answer is I could have, and I'm going to show you now. Watch. Let me do it again. Delta y, delta x. But this time, instead of 2 minus 6, watch this. 6 minus 2. All right, there's my delta y's. And then, since I use 6 first, I use 0 first on my numerator. 0 minus a negative 1. Look, careful there. Look at this. 0 minus a negative 1. 0 minus a negative 1. Because that's what your x is. Your exponent is a negative 1. Notice it still comes out to 4. Check it out. 6 minus 2, 4. 0 minus a negative 1 is really 0 plus 1, which is just 1. So it's just 4. So it doesn't matter which ordered pair you use first in the order that you substitute into the formula. That's the point here. Do one more example. Questions? Those are excellent questions so we can see it visually. Thank you for asking that. Example 2. Any questions on example 1? One more. I'll write that down. Find the slope of the line passing through negative 2, 1 and 1, 0. So 1 minus 0, negative 2 minus 1, so that'll be 1 over negative 2 plus negative 1 is a negative 3, so it's a negative 1/3. Same as when I plotted it. Let me do it again down here, but this time I'll use the second ordered pair first in the order of subtraction. Delta y, that's 0 minus a 1 on my numerator. Delta x, 1 minus a negative 2. That's my denominator. Notice they'll still become negative 1/3. 0 minus 1 is a negative 1. 1 minus a negative 2 is 1 plus 2, which is 3, negative 1/3. Doesn't matter where the negative is. If it's on the top or the bottom, it makes the whole fraction negative, right? Okay. Last thing, just copy this slide down. It's not an example. We're going to copy the small tree map. 4-branch tree map on your notes. 4 kinds of slopes. I kind of went over this yesterday, but now this is a tree map summarizing the 4 slopes. I'm going to copy that down.